Right, morning everybody. So let me share my screen here and present. Okay, you should see it. All right, so week 5, almost halfway. This week and the next week is the last week. We're actually just looking at normal entities, entity managers, and then the week after we're going to start getting into the queries and getting a bit more creative around getting data out of the database. So we had a good week on the quiz again. 15 people wrote. Last week was 17, so I know 2 people didn't write.
It was the BBD party.
But I extended it until Monday. I did put an extension on there. I've got a bit of a cold, so that's why I'm sounding all like sneezy. All right, so looking at the bottom 2 again, because there was a bunch like on 73.33%, so otherwise I'm going to go for the entire quiz. 3 people got 100% again. Didn't check if it's the same 3 people. I don't think so. I think maybe there's one overlap. Anywho. All right, so looking at the bottom question, so it's number 10. It's the bottom of the bottomest. And this is the sort of many-to-many relationship and just understanding what happens there. So this one wasn't, I mean, initially it looks quite difficult, but there's a few things you can really, just looking at the type of answers, you can really just kick out already. Target entity that you see there on the first and the third option, you can really, you don't have to look at those because they only use the target entity if you don't have it, if you're not using generics in your collections, in your relationship. And both of these are generic, so those 2 you can really kick out. The other thing you need to know about many-to-many is you still need to have an owning and an inverse site. Owning site and inverse site. So one of them has to have a map by item. So you can really just start looking at the ones that have a mapped by on the options. So that leaves the third one, fourth one, and the second one. I think one of these has got it on both of them. If I remember correctly, many-to-many items field, many-to-many map by items category field, many-to-many map by categories item field. I'm so like sneezy I can't see. So the main thing is the bottom one here has got mapped by on both of them, and that's why it's illegal. I don't know. I think it doesn't complain, but I don't think it's going to work as expected.
I would want it to complain.
I think it might be done with the provider. But the main thing is, so the thing to take from this question is the target entity you only use if you're not using generic collections, and the other thing is you have to have a map by on one of the sides of the relationship, and not on both. And then the other one is question 1. And this was looking at the join table and understanding how the join table works. So the one thing is being a one-to-many, and we see there's just a one-to-many on one of the entities, so it's unidirectional. And as soon as you see a one-to-one of unidirectional with no map by or anything like that, you know it's going to be a join table. So that's one of the things we saw last week. So around here, if you don't want this thing to create a join table, you need to actually go and do something else. Now, the one way of doing it is to define a foreign key. And you can either do a foreign key on the inverse side by adding a map by field on that side, but because this is unidirectional, we can't do that. So the other way you can do it is to add a join column. And the right way to do that is this third option. Saying join column, giving it a name. And that's it. So that's sort of one of those things. That's sort of the way you need to look at the questions. And the whole 2-minute rule is looking at and seeing what's the context, what are they trying to test you on here. You know, if you see join table, really start thinking about how does a join table work. Do you see any other questions you've seen about join tables before? Is this maybe a similar question that you've seen before about join tables? And then make a decision on that. All right, there's a few 73% ones. Okay. Let's see if there's any questions. None. All right, so today we're looking at inheritance, and they've got like one of the topics they threw in here as well as embedded objects. So first off, before getting going on inheritance, when it comes to production systems, don't do it. I don't think
I've never seen it.
Yeah, if you're going to do this like for a prototype or something, by all means. But yeah, I think you're going to burn yourself so bad if you do this in production. And I think of anything with ORM, and that's where you've got that impedance, ORM impedance thingy, is design the database and your objects separately and then try and match them up if you have to. But don't make your RM actually generate that for you. But for the certification, you're going to know, you need to know this, you need to know how this works. It's sort of getting back to the whole object-oriented databases, which didn't work, and and I think this inheritance thing sort of is trying to sort of simulate that same type of idea. So we can looking at the inheritance, the different strategies you've got around those, and like snuck in there at the bottom is embeddable classes. It's like Randy Orton from downtown. All right, so just to get into the general stuff about inheritance when it comes to RM, or the JPI stuff. So you can inherit, entities can inherit from any other entities. Doesn't matter. They support polymorphic associations and queries. So if you've got an employee with a full-time employee, you can actually query the full-time employee table, but return an employee object, if that's what you want to do. We've just seen before, it can be abstract or concrete classes, doesn't matter. You can extend non-entity classes, so inherit from them, or the other way around. And the main thing is, when it comes to JPA, it doesn't matter. You can still do normal OOP stuff. So if you couldn't do object-oriented programming, then the whole thing around JPA would be lost. Wouldn't make sense. Like I said, otherwise it would suck. So when it comes to abstract and concrete classes in your inheritance hierarchy, abstract and concrete classes can contain state and can be persisted. The main difference is that from a normal Java point of view, you can't instantiate an abstract class. That's just normal Java object orientation type stuff. That's the only difference between the two, really. Otherwise, whatever you can do with a concrete entity class, you can do with an abstract entity class. Query it, persist it, remove it, do whatever you want. So that just comes down to what you can do in Java with it. It doesn't have anything to do with the JPA or being an entity. And then there's two interesting things you can also do. So the one is mapped superclasses, and the other one is non-entity or transient classes. So this is with a mapped superclass. This is where you've got a class in your hierarchy. I've got a little example of a hierarchy here. So this is from the book. So you've got an employee being your top level root node. Then you've got a full-time and a part-time employee leave. Little classes there. And the idea is that this employee is maybe an abstract class, the contracting employee is an entity, a concrete class, and your full-time and your part-time are also concrete classes and entities. So for map superclass, you might have something like a company employee class in the middle here. And the main thing with the map superclass is it doesn't get persisted, or it contains state and behavior, but it doesn't have its own table. So you're never going to see a table company employee in your database. But full-time employee and part-time employee are going to inherit that vacation field, and they're going to persist it in their tables. So it's sort of one of those things where you probably might do that if you've got a hierarchy, but let's say your database tables aren't set up that way. So in your database, you might only have a full-time employee table and a part-time employee table for whatever reason. But both of them have got a vacation field, and you want to sort of represent that in your object hierarchy. You can do it like that. Like I say, sort of when it comes to inheritance and RM, it gets a bit wild. And then the other one is a non-entity transient class. So it's almost like the opposite of a map superclass in a way. So a non-entity one doesn't get persisted at all. The fields you've got in the non-entity class, if they get inherited by another field, they're not persisted. They're pretty much just for behavior. That's what you use a non-entity transient class for. It's pretty much if you've got something in inheritance hierarchy, but you just want to get the behavior from that class. None of its fields, nothing else. Places you might use that, like it's sort of, the cases for it is almost like you probably shouldn't be using inheritance for it in the first place. But there might be something, because this is object oriented, you might push it in there somewhere. The other thing about the non-transient class, you can't use it like an entity at all. So you can't get it back from a query. You can't use it. You can't say persistent. You can't anything with it. It's just for behavior. And to make something a non-entity transient class, you just don't annotate it with anything. It's just a class. Map superclass, you actually have to go and annotate your class with the @map superclass annotation, or you can make it a map superclass in your code, like in your XML. So instead of in your ORM, I'm just going to quickly jump here. View. So instead of having something like an entity, you'll actually go and say map superclass, and it'll be exactly the same as an entity. So you'll have your attributes underneath there the same way that your entity will have its attributes. And I say if it's a non-transient or a non-entity class, it just won't be mapped as an entity anyway. So that's sort of the main things to know around. So when it comes to map superclasses and non-entity classes, there are probably places you might want to use this, but this is probably if you're looking at some legacy database structures where you don't really want to mix or have your classes look all funky to fit in with the actual tables. So when it comes to inheritance, there's a few different strategies or ways that you can tell the JPA to listen here. I've got this bunch of classes inheriting from each other. This is the way I want you to persist in the database. And pretty much what you're going to be telling it is these are the type of tables I want to have in the database. So there are 3 different strategies that you can look at. The first one is the single table strategy. And as the name suggested, it's a single table. So in our example here, we won't have 5 different tables or 4 different tables. I only have one table called employee. And that'll have all the fields from all these different objects in there. So it'll just become one giant super table, which probably isn't bad. The main thing with, yeah, so it's probably the one that I'd still probably be used mostly, just from the way that most things are. The only thing is that when you've got one table, to actually go and identify what the concrete class is for each one of those records you put in there, you're going to have to use what they call a discriminator value or discriminator column. So in your actual table, you're going to have an extra column in there which says this is an employee, or this is a contract employee, or this is a full-time employee, or this is a part-time employee. The other thing is also for something like a contract employee, it's not going to have a salary or a pension attribute, but it's still going to have those fields in its table, or in its record. So those fields are actually going to be nullable. So the problem that causes is if you've got kind of a really deep inheritance structure, you're going to have a bunch of fields in there which is going to have nothing in there. And in this day and age where storage is so expensive, that might be a problem. Not. But the one thing that it does make it easier, it's quite fast to query that single table because you've got no joins. You insert to update it as fast as there's no joins in there. There's no multiple tables you need to update. And everything's also just in one place. Another thing is also when you're using your discriminator column, you can also go and define what your value is that it should store in there. So by default, it'll store the actual non-qualified name of your class. So for contract employee, it'll be contract employee. But you can also go and define different types. You can make it a char or a string or an int. If you're saying it's an int, you can give it a number. If you don't give it a number, it just assigns like an ARB random number, like minus 565 and 7 and 700 and a half. Like, I don't know, so numbers Zuma won't be able to say, like that type of. It's really crazy. So you can go and define a descriptor value there, and that'll set all that up. So it'll give you a table that looks something like this. So to represent this big structure here, this hierarchy structure from here, it'll give you one table with every single field in there with your discriminating column in there. So you can give the column a name. If you don't give it a name, it'll just be D type for a string. Maybe I was going to do the demo of this after, so maybe I should do it as I'm talking about this. So I'm going to show each one. So for this demo, we've got a normal employee and department type thing, which I started out with. Just changed a bit. So we've got our structure that I've showed on the slides here, employee, contract, company, employee, all that type of stuff set up here. And all my little test does is it just goes and creates 3 different employees, which one is the contract, one is the full-time, one is the part-time employee. I read them Mr. Yellow, Mr. Blue, and Mr. White. Or Quentin Tarantino-ish. So on our employees, so if you don't go and define an inheritance strategy at all, so we just leave that out, the default would be a single table value. Actually, put that back in. And then we can also go and define, like I said, your discriminator column. And this is the column that you want to use in your single table to go and find. So we can maybe just say employee type. And you can also go and define the type, the discriminator type column. And there you can see we've got an integer, a char, or a string. I'm not going to do that. And on each of our tables, you can then also go and define your different types. If we go to our company, contract, employee, we can then go on there and actually say, okay, well, your discriminator value is implemented. So a funky name. So if we go and run this, and goes and generates the tables for us. So it just prints out our 3 different employees there. SQL. So you can see we've only got our single table there because that's what strategy we said we want to use. And on our columns, we've got our employee type column there because that's the discriminator column we asked it to create for us. We go and query that. You can see we've got our discriminator column at the top there. There's our comp impl discriminator value we put in, and the other one is just use the unqualified class name as a default. So quite simple and straightforward and easy. This is created this little one table structure for us there. The other one is the joint strategy. So as it says, it's going to use joint tables. And one other thing I forgot to mention is if you've got an inheritance hierarchy, the top or root class is going to have the primary key, and that's it. You can't have primary keys in the other tables because it's not going to like that. There can only be one. It's like Highlander. So, what's the main guy's name again?
McLeod.
McLeod. Hey? Duncan McLeod. The clan McLeod. So that'll be like the top guy will be Duncan McLeod. It's the only one who can have the primary key. So the joint strategy, each sort of class or object here will have its own table, and it'll just have its own fields in there. So we'll have an employee table, but then the primary key for the employee table will be the primary key and the foreign key for each other table, so the things link up. So if you've got one employee, a bit of its data will be sitting in employee table, a bit of it will be sitting in company employee table, and a bit of it will be sitting in part-time employee table. It's because it's all joined. But because you don't have the whole everything in one table, you're not going to need a discriminator value or discriminator column. It's also if the type of queries you're going to be doing over it is just specifically for part-time employees and only the part-time data, that might work for you. You can still do your sort of polymorphic relationships between them, but it's going to be quite a bit slower than the single table one just because you've got so many joins. In certain updates, it's also going to be a bit slower because you've got multiple tables to go and store these things in. But if you want your database to be more normalized, this is the way to go. So this is going to give you a much more normalized database. But whenever you, like I said, don't do this, but whenever you do any of these type of strategies, it's sort of looking at what type of queries you're going to be running against your table. So if you're going to be running a lot of polymorphic type things, then it maybe makes sense to go single table. But if you're going to have millions and millions and millions of records in here, then you probably don't want to have joins on it.
in this universe that you live in, there are no DBAs who look at these tables and go, what the hell?
Yeah. So
that's your bigger problem, hey? The DBAs are bastards, and they every time I've tried to do this in my career, they've gone,
yeah. So I say sort of it's at looking at what type of queries, what type of system it is. But most of the time, you're going to be like, am I going to use inheritance for this? And the answer is going to be no. Just from a production system point of view, you're going to screw yourself up royally. So for this one, what you need to do is you can go and define your inheritance strategy on your class, and you can say it's joined. And that's it. You don't have to do anything else on there. So if we go back to class here, so our discriminator values won't really make sense here anymore. Take that one out. If I go to employee, just take that out. Column. Anything you're going to do is just going to say it's joined. I think it's also you need to define your inheritance strategy at your top level class. You've defined it further down. It depends on your provider, what your provider is going to do there. So with Hibernate, it doesn't do the mixed thing. So if you don't define it on your top one, it's going to default to single table, and that's what it's going to do. So if you put joint down on contract employee, it just ignores you. I think with Eclipse Link, you can do the mixed thing, and it actually works. But from a specification point of view, there's nothing that says you have to support it. There's also one of the things whichever provider you're using is looking and seeing what that provider will do. Let's go and destroy my database. I'm going to do the drop the database and walk away joke again. So it was funny last week, but I don't think it's going to be funny this week anymore.
You're an American comedic artist, eh?
I know. Because I'm black and shit.
I don't know if our group in India will know that sense of humor.
Okay, so we're just running it again, so it creates that database for us. So we refresh it. So first thing, you'll notice we've got more than one table there now. And we also have our discriminator columns. So our employee column has got the three fields we define in our class: ID, name, start date. Contract employee will have its daily rate term and the ID, which will be a primary key for itself and the foreign key. But if you go and select from employee here, you'll see we'll have all three employees in there: yellow, blue, white. But if you look at contract employee, you'll only have the one record in there. And the same for full time and for part time. So whenever, if you're going to say, let's say, give me my part-time employees, it's actually going to do a join on part-time, contract, and employee table. So the employee table and the part-time table are going to join to give you that value back. So anyway, we go and print out our employees there. It's actually doing a join on two tables to get that back. And yeah, so I guess then the third one is a table per concrete class strategy. So first off, is optional in EJB3 spec. What am I talking about?
Oh yeah, that's cut and paste, eh?
Yeah. I think it's still optional though, even in the new JPA spec.
Because JPA kind of deviated.
Because I read it somewhere. I don't know, I just copied it.
Deviated away from EJB3, and that's when the spec was created.
I'll fix that up. But it's still, I think it's still, because I think I read in the JPA 2 book, it's still,
yeah.
I mean, that's why I didn't even read what I put in there. So it's, most providers will support it, but to be compliant with the spec, you don't have to support it. So the main difference between this and joined is, on our join strategy, we only have the fields in there that are specific to that class. But with a table per concrete class, we actually have every single field in there. So we've got an employee table. Our contract employee, which inherits from employee, will have its fields plus the two fields from employee. If you go to like a full-time employee, it'll have all the fields from company employee, which is vacation, and the name and start date from our employee table. So it creates like quite big and large tables. I don't think you'll ever do this.
Well, if you don't have access to those parent tables, you literally have them across another database, and the link is like, you know,
across another database. That's already a problem.
Yeah. I agree. I can't think of any other reason.
Yeah, and so I think this is just might be some weird legacy tables you might have to interact with, where before relational databases might be one of those ones. So the table per class is the third one that you've got there. So each class has got its own thing. I can't remember if it creates a foreign key between them though. I don't think so. Check now. So like with the join table, you just have to go and specify your inheritance type as table per class. Main thing is this is very poor for polymorphic relationships because there is none. And pretty much all of them, if you're going to do a select, it's going to have to do a union. So if you say, give me all my employees, it's going to actually have to do a union on all these tables to get you all your employees back. So one of the advantages I say they have that you don't have your discriminator column anyway. That's a big advantage.
Someone got burned by the discriminator column. Looking back in the 90s.
But the other thing is, if you're never really going to do polymorphic type queries on this, which I don't know why you had inheritance in the first place then this is fine. So if you're only ever going to work specifically just on full-time employees or only on part-time employees or contract employees, never together as employees or company employees, then this is the perfect strategy for you. I also think your design is very flawed. So the main differences here is instead of having a join strategy there, you've got a table per class. You're going to kill this database again. Create it. And go and run. Project is to go, oh, what did I do now? Cannot use it. Oh, nice. So this is.
So you take it off the other entities.
Yeah, because each one needs its own one in there.
You just beautify now your hierarchy and see which one you take off.
Let's just say this works.
It's already getting too complicated.
Let's do the following. Let's just set the ID for each one of these. Just take that off.
Homework, find out.
I can't even remember if I tested this. Just in a bit of a blur. So let's just set the ID for these ones. One. Complaining about.
You're doing an int conversion. Put L there.
Two and three. Three. Okay. So create a database. Did it do anything here? No, it didn't. Okay. Let's see how this works out. I'll just roll back. Manually assign. Well, I did manually assign them. Say again, Andre? Okay. Anyway, I'll figure it out. But so maybe it's just Hibernate decided they're not implementing it. I think I struggled with it, and it was later. I just decided to leave it. That's my homework, to get that working. All right, so we would have done a demo about inheritance, so we've been doing some demos about that. The last bit for today is embedded classes. And embedded classes are there for places where the table, where you've got a class, isn't necessarily a separate table, but in your objects, you want it as a separate object. But you don't want to have like a map superclass or a transient class or something. It's actually part of your class. So an example might be where you've got an employee and it's got an and the employee's got an address, but the fields for that address is actually in the table for the employee. But from an object orientation point of view, you don't want to have one superclass with all your address details in there, an employee class with all your address details in there. So you actually create a separate class called address, put all the values in there, and you actually put that address field, address object in your employee class. So normally that will mean there's a relationship, but you don't have a relationship because you don't want a separate table for this. So the main thing that they say is an embedded object is like an entity, but it doesn't have an identity of its own. It needs to be part of another entity to have an identity. As it goes back to the object relational impedance mismatch. So it's where your object orientation, things don't necessarily fit in with the way you've got your table set up. The way you do this, when you actually define your class that you're going to embed, you have to mark it as embeddable in your as an annotation, or you can mark it as embeddable in XML. And then when you actually use that class, let's open up here. So we've got our address class here, and our address class we want to actually use in our employee. So there we have to go and mark it as embeddable. And then when we use it in our employee, we've defined it here as a field. You can go and put the embedded there or not. Doesn't matter. By default, the JPA provider will put it in there anyway. Doesn't care if it's there or not. Then you can also go and override those embedded classes. And an example is in the book is, let's say you've got an address object, like we've got here, but your employees have got addresses, and let's say your different companies have got addresses, and you want to reuse this address object for companies and employees. What you can then do is, in the employee, let's say the fields in the employee table are street and city, but in the company it's different. You can actually go and override it. So you've got this attribute overrides annotation you put on that field, and you say on your property, your embedded property there, or your embedded field, and you actually can go and override this one and say, okay, well, the column that's called state is going to be province, and the one that's called zip is going to be called postal code in the company table. It doesn't line up with the ones at the top. So you can probably say the field that's called street, the field that's called city, is going to be called road.
Yeah, very American.
And city is going to be called town. Something like that. You can actually go and override it and reuse that address object. So just doing a quick little demo on that. So we can do this on our employee. We can go and add an address on it. So got an address. Then on our address itself, we can say we have to go mark it as embeddable. I must take off this inheritance here. This is breaking stuff. Let's say join. So we've got our employee, and on here, like say, you don't have to, but you can say it's embedded. You don't have to do that. And on your address, you have to go mark it as embeddable. Run it first. Now things have broken now. We can actually go and kill that database. Detached entity passed to persistent. I don't know. Something wrong here.
I think multiple hierarchy.
Yeah. So that's, inheritance is bad.
I've never seen it used. Composition over inheritance.
Composition over inheritance. That's right.
You must know that although databases are faster than relational databases, it's been proven. There's quite a few there that are like pure OO databases. We're talking, they don't support relational, also though, on faster than relational databases. But who uses a pure database? You have to buy one specifically for that. So I used to actually do, as part of the boot camp, show them a pure object-oriented database.
I've got no idea what happened.
Object-DB. Incredibly fast. It's like optimized for OO.
Things are very broken here at the moment.
Fine. Abandon training.
Jump ship. Might be. I think it's my cold. Blunted my skills. Yeah, now it's broken. This worked before the weekend. So I didn't feel very lucky last night, so I didn't go through the demos again. That'll teach me a lesson. I've been taught.
You've been schooled.
I've been schooled. Okay, any questions not related to the demos not working? Nothing, all right. So this weekend, quiz again, but this for the weekend. It's not going to be extended until Monday again, unless somebody else has got a party. Any other big parties happening this weekend? Nothing, all right. So opening at Friday, closing Sunday night at 12. Next week we're looking at enumerated types and relationships. So enumerated types we touched on in the second week. I just sort of looked at it briefly. So you can just look at it briefly again. And then we're looking at relationships, and that's collections and mappings, and how they relate back to tables. And this is sort of the last week we're looking at actually setting up entities and working with entities, and then the week after we're going to start looking at queries, all different types of queries. Then the attendance keyword for today is inheritance. It's not creative, Rory.
Whatever the topic was.
Inheritance. All right, that's it. Thanks, guys. Bye.
Cheers, everyone.